Salam Namaste to all my dear super champions, and this Ignite batch is specially for those who want to study in English. So welcome to this amazing platform of Physics Wallah. My name is Mini Sharma and today we are going to master carbon and its compound in one shot. So how's your Josh? How's the preparation? Do let me know in the comments. So without further ado, let's start it. We are going to classify, categorize this chapter into 4 categories. One is the bonding. We want to know what kind of bond a carbon can form. Right? Next we have the allotropic forms of carbon and then the chemical properties. We are going to have 4 chemical properties or the chemical kind of reaction and some important chemical compound such as your ethanol and ethanoic acid. Their properties and their uses as well. Last but not the least, we have the soap and detergent and their cleansing action. So, this is how we are going to proceed. So, very first, let's take the introduction because introduction is always important. So, let's know more about carbon. So, here you can clearly see the atomic number of carbon. I can write that's 6. Okay. So, brilliant, you do know that. So next we have the mass number which is equal to 12 EMU and then we have the symbol capital C and electronic configuration. You have to fill the electrons in the K and the L shell. So we have 2, 4. 2 in the K shell and 4 in the L shell. Then the valency, you know that. How we find the valency? The outer shell electrons, the valence electrons having equal number of electrons like 1, 2, 3, 4, that's equal to the valency. If the number of electrons are 5, 6, 7, 8, we have to subtract it by 8 and then we get the valency. So here the valency is 4 only. Now, valency is what? The combining capacity. Next we have physical state. Generally carbon is found in solid state at room temperature. RT, right? Nature, it is non-metallic in nature. Next we have isotopes, the species which have the same atomic number but different atomic masses are known as isotopic. So, carbon has 3 isotopes. Let me write it for you. So, carbon 12, carbon 13 and carbon 14. Good. Next is the allotropes. We are going to know what are allotropes in a moment, but yes, carbon has according to our syllabus, we have the 3 allotropic form of carbon. One is the graphite. Then we have diamond and fullerene. Okay, next is the speciality. What is special about carbon? So that's the versatile nature of carbon. We will know about it more and more because it is the one of the important and favorite question of the examiner. Why carbon is versatile in nature? If you know it, do let me know in the comments. Now, let's start it with the bonding concept. See, carbon is forming n number of compounds, right? When we are talking about compound, there will be some kind of chemical interaction, chemical bonding. So, what kind of bond a carbon can form? So, let me show you. Carbon has a valency equal to 4. It's very much important. Carbon has a unique electronic configuration. What that uniqueness? So, carbon has 4 electrons in the outermost shell, in the L shell. So, basically every elements are made up of atom. They tends to complete their octet. Why octet? In order to gain stability. Now, there is one more concept that every atom tends to get the electronic configuration to the nearest equal to the nearest noble gas. So, whether to follow the octet rule or nearest noble gas configuration, both are the same thing and they are for the stability concept. So, are we getting it? Now, let's discuss about carbon. So, carbon I can place carbon here. The nearest noble gas can be helium, and on the other hand, it can be neon. Yes or no? 2 is the helium and 10 is the neon. Carbon is the atomic number equal to 6. So I can write it like this. Suppose 2, 4, it is 2, 8. See, the octet is completed here, and helium is having only one shell. First and the last shell, K shell, having only 2 electrons, so completing its duplet. Duplet is also for stability. Duplet stands for 2 electrons in the shell, outer shell. So, duplet means number of electrons are 2 in the outermost shell, and it is also for the stability concept. Now, carbon has to gain 4 electron in order to get the noble gas configuration neon, and it can lose 4 electron, these 4 electron, to gain the electronic configuration equal to helium, to gain the stability. Either duplet or octet needs to be completed, no? So basically there is a case of gain or loss. So this is the case about carbon. So what is going to happen with carbon? What carbon is going to do? Gain, loss, or whatever else. So basically this is the scenario about carbon. So in the case of carbon, carbon has 4 electrons in its outermost shell and needs to gain or lose 4 electrons to attain stability, to attain nearest noble gas configuration. Done? Let's check if it could gain 4 electrons. So it will be forming C4 negative ion. Yes, of course. If it is supposed to gain electron, it will be acquiring negative charge equal to 4 negative. Now, but it would be a difficult case for nucleus with 6 proton to hold on 10 electrons. Let me show you this concept. So basically, suppose this is your carbon. Shell 1, shell 2. Having the nucleus, 6 proton and 6 neutrons. So suppose this is for carbon 4 negative, right? So 2 electrons here. Previously it was having 4 electrons. Let's check, because it has gained extra 4 electrons. So these orange are the extra 4 electrons. Now understand the concept. The carbon here, the nucleus is having only 6 protons, so it is very much difficult for these 6 protons to hold 10 electrons. So this case cannot be possible. Now let's check out the another case when carbon can lose 4 electrons. So it will be C4 positive, the case of C4 positive. So let me draw the structure again. So let's check 6 protons and again 6 neutrons, because there is no change in the number in the nucleus, because it's all about the transfer of electron or the sharing of electrons only. So here we have only 2 electrons, because carbon can be written as 2, 4. These 4 electrons carbon has donated, so that's why it is only having 2 electrons. Now in order to lose 4 electrons, there is lot of amount of energy required, and which cannot be afforded by carbon, because it's a, if we are talking about loss of electron in the higher classes, we will understand the ionization energy, because we cannot lose 4 electrons at the same time. It will happen one by one, and it will require a lot of amount of energy which carbon cannot afford, right? So this case is also denied. It could lose 4 electrons forming C4 positive cation, but it would require a lot of amount of energy, and to remove the 4 electron, leaving behind a carbon cation with 6 protons in its nucleus holding only 2 electrons. So both the cases are denied, both the cases are invalid. So what carbon is supposed to do? Carbon, you can check, this is your carbon right now. So carbon neither choose to lose nor gain. Rather, it chooses to share the electrons. Yes. So, carbon share the electrons. It's 4 electrons and form 4 electrons. And form a kind of bonding we know as covalent bonding, right? In the case of metal and non-metal, we already have understood the concept of ionic bonding, because metals are having excess of electron, they can lose electron, and non-metals are electron poor species and they can accept electron, and there is a kind of ionic interaction between them and forming the ionic compounds. Now, if we talk about the covalent compound, so covalent compounds are the kind of bond they have by the sharing of electrons between the two atoms, right? It can be carbon and carbon, it can be carbon and hydrogen, any other atom. So basically the concept is carbon is forming n number of compounds by sharing of electron, making the covalent bond. Are we good with this? So carbon, the bonding in carbon compound is covalent kind of bonding that happens due to sharing of electrons. Are we good with this? Alright. So basically, okay, give me a moment. Let's check what we have. Next we have not only the carbon, but many other elements form the molecules by sharing of electrons. Not only it's not the concept of carbon, but there are some other elements which also supposed to share electron in order to form molecules. So just like we have the hydrogen. So hydrogen, atomic number 1, we can write it electronic configuration like this, K shell having only 1 electron. So in order to get its stability, hydrogen cannot complete its octet. Why? Because the 8 electron is big thing for hydrogen. But it can definitely complete its duplet. Duplet stands for 2 electrons in the last shell. Because carbon is having only 1 electron. So K shell is the first and last shell for hydrogen. So duplet means stability. So what will happen? Suppose there is one hydrogen moving here and there and sitting along with his one electron. So there will be some other hydrogen sitting here with its 1 electron. So they are talking to each other and sharing their sadness, why they are not stable, why they are having only 1 electron. So they got an idea why not to share these electrons. So basically they are sharing these electrons, right? So I can write it like this hydrogen and this hydrogen. So basically this hydrogen is completing its duplet and this is the area, common area we are drawing, okay, and this is a kind of electronic dot structure because we are showing the valence electron in a dot form, okay. So now this is the common area representing the shared electrons. If these shared electrons are 2 electrons are shared, they will be forming a single bond. If 4 electrons are shared, there will be double bond. If there are 6 electrons shared, there will be triple bond. So, I would like to highlight this point that in order to form one bond, there is requirement of 2 electrons. One from the each side. Yes or no? Okay. So, now we have oxygen. So let's check whether covalent bond can be single only or double or triple or multiple. So basically if I talk about oxygen, let's talk about oxygen. Atomic number is 8. So electronic configuration will be 2 and 6. Now how many electrons this oxygen require to complete its octet? I want to ask it from you. Do let me know in the comments. So I suppose it requires only 2 electrons. Yes. Now let's suppose we have another oxygen and having the same electronic configuration which is 2 and 6. Alright. So this electronic dot structure actually emphasize focus on the valence electron only. So these are the valence electron, the outermost shell. So they will be shown by the dots. Okay, so here I am taking one oxygen, taking the another oxygen. So one oxygen is carrying 6 electrons. So this is the idea to make these diagrams neat and clean. You have to draw the dot structure in such a way that there is a kind of proximity. Proximity means there is availability of electrons nearby both the atoms. So basically I can write it like this: 1, 2, 3, 4, 5, 6. Not in this direction. Why not like this? Because this is not representing the clear idea of covalent compounds, right? Or making a covalent bond. So basically I will be writing it in the pairs, electrons in the pairs, and this oxygen is sharing the electron with this oxygen. That's why I am placing this pair of electron towards the oxygen. Proximity. To maintain the proximity. Now let's discuss this oxygen. 1, 2, 3, 4, 5 and 6. Now this is the time to check whether they are completing their octet or not. So this oxygen having 6 electrons from itself, and these are the 2 electrons which are in the sharing. So 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons are completed. Now on this side, this oxygen is doing the same duty. So basically both the oxygens are carrying 8 electrons when they are sharing. So how many bonds I can form here between the 2 oxygens? So O2 molecule has 2 covalent bonds. I can write it like this. Right. Now the shared electrons are forming the bond. What about those electrons which are not sharing, which are not shared, like this? What are these? How can I name them? So these are the lone pairs. Lone pairs. Because they are in a pair, so I am calling them pair. Lone means because they are not participating in the bonding, participating in the sharing. Are we good? Okay. So this is how I can form the 2 covalent bonds. 2 covalent bond, 4 electrons are shared. Are we good with this? Alright then. My dear students, let's check the N2 molecule formula. How can we make the covalent bond between one nitrogen and the another one? So nitrogen atomic number is 7 without any doubt. K shell carrying 2 and L shell 5 electrons. Similar for this. You have to write it likewise in the examination if you are being asked about the covalent compound. How can you form the N2 molecule, the electron dot structure for N2 molecule, or the O2 molecule, ethanol, ethanoic acid, carbon tetrachloride, so and so and so. So basically we have 2 and 5. So again the same formula, right? Nitrogen in front of each other in the proximity. It should be neat and clean. Because the examiner, when your paper is going to be checked, it should be neat and clean. It should be comprehensive, right? Then only you are going to get the marks. So basically, I can write it like this. Here you can see 1, 2, 3, 4 and 5. Proximity. 1, 2, 3, 4 and 5. Now, let's check the sharing. This nitrogen is completing the 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. Done. Again, if I talk about this nitrogen, so it will also be completing its 8 electron and getting the stability and will be existing as N2 molecule. Can you tell me how many electrons are shared here? So number of electrons are 6 electrons. So what kind of bond I can form between nitrogen and nitrogen? It will be like this only. If I ask you how many number of lone pairs on one nitrogen are present in this molecule? Do let me know in the comments what is your answer. Okay. Now, so I have clearly checked that covalent bond can be single, can be double, and can be triple, depending on the number of electron we are sharing. So maximum in your syllabus we will be considering up to bonding equal to 3. Yes, in the higher classes we can see 4, 5, 6. Now, difference between the covalent and the ionic compound, we will take only one glass of this. So basically, what is the difference between covalent? Covalent is due to sharing of electron. Sharing of electrons. What if I talk about ionic? So ions will be formed, and ions are only formed when there is transfer of electron. So transfer of electrons. Generally, ionic compounds are formed by one metal and one non-metal, because metals are electron rich. They can donate electrons, lose electrons, and carry positive charge and makes cations. And here you can see the non-metals are electron poor. They accept or gain electrons. They form the anions. And the best bonding is between a positive cation and a negative anion, forming the covalent compounds. Here we see it is formed between a non-metal and non-metal, carbon and hydrogen, nitrogen and nitrogen, oxygen and oxygen. What are these? These are your non-metal and non-metal. Sharing of electron, complete transfer of electron. Now, let's discuss, they do not ionize. Why? Because they are not gaining or losing. There is no concept of gaining and losing in the case of covalent. So, they will not ionize, but yes, because the ionic compounds are formed due to the attraction between the different nature of ions, that's why they will be ionizing. Of course, they are bad conductor of heat and electricity. Why? Because as I told you, conductivity tends to movement of ions. Yes, so they are bad conductor of electricity because they are not having any kind of ions. While the ionic compounds are good conductor because they carry ions. They carry the charge. And if I talk about covalent compound, they have weak force of attraction. If I compare covalent compound from ionic compound, so ionic compound will be having stronger bond because there is no strong bond as we compared when a cation is attracting an ion. Are we good? That's good. Now, let's discuss another thing, which is allotrope. Again, very important topic, one of the interesting and favorite question of the examiner. So, what are allotropes? So, generally, allotropes are the different form, physical form. That means they will be having different structure. Structure means they will be having different arrangement. So, you need to understand allotropes are the different form of the same element where the atom combine in different ways. At the same temperature and pressure, they can exist in different form, in different structures. Different structures where the arrangement of atoms is different. Are we good? Is different. As I told you, carbon has a 3 allotropic forms. One is your, here you can see, one is your diamond, another is your graphite, and the last but not the least, fullerene. So basically, we can clearly say that whether the arrangement of atom is different, their physical, you can say their physical form is different. So we can say the physical properties are different, but the chemical properties will generally remain same because the whole diamond is made up of carbon. The whole graphite is made up of carbon, as well the fullerene is made up of carbon. So we can suppose the chemical properties will be same somehow, but the physical properties are going to be different. Why? Because of different arrangement of atoms. Now you can see diamond, the most precious and the hardest substance on this planet. Next we have the graphite in the pencil lead. We generally see and we generally use it since so long, and then we have the fullerene. Now we are going to study them one by one and their properties as well. So basically diamond word means unbreakable in Greek. That means it is the hardest substance, right? Diamond is a colorless, transparent substance having extraordinary brilliance because it is having high value of refractive index. In the physics you got to know about refractive index and etc. So basically diamond is quite heavy and extremely hard, yes of course, and it does not conduct electricity. Why? This is important, right? We are going to discuss it. And it burns on strong heating to form carbon dioxide. That means it is good conductor. See, anything which is made up of carbon, when we are going to burn them, we have activity in the NCERT when anything is made up of carbon and we are supposed to burn that, it will produce carbon dioxide in the sufficient amount of oxygen. Done. So basically, because diamond is also made up of carbon, so it is supposed to form carbon dioxide on burning. It is good conductor of heat. Now I am going to answer this point and this point. So the answer is going to be because of its structure. Because of its structure. So let's understand something, very few points about the structure. You can clearly see here, we can see the case-like structure of diamond. So how can we form it? So carbon is attached to further 4 carbons in a tetrahedron fashion in diamond, in the case of diamond. So we will not discuss the hybridization etc because that's not important in class 10th. Right now we need to understand why carbon is basically diamond is a good conductor of heat and bad conductor of electricity. Now, so basically this is the structure. So I can write in diamond carbon is attached, one carbon is attached to further 4 carbons. Is it true? Let me know. Of course. Here you can clearly see. Let's suppose this is your carbon. So 1, 2, 3 and 4. Suppose we are having this carbon now in the center, right? So it is attached to 1, 2 and then we will be having 3 and some 4 carbons. Every carbon is attached to further 4 carbons. You need to understand this. Also, it is forming a case-like structure. Case-like structure, that means structure. That means there will be some, hollow site, or you can say there will be some cavities. Here you can see this is the cavity, the hollow space. Again, every side. The carbon is arranged in such a manner, it will be forming a case-like structure, a huge, giant case-like structure. Now, you can say it is forming a tetrahedron fashion. Now, if I want to extend this, so it will be like this. Carbon, further carbon, carbon and carbon. Okay. Now also, if you are not understanding tetrahedron fashion, so I would like to let you know methane, CH4. So carbon and hydrogens are arranged in the tetrahedron fashion there also. Okay. So now we have this carbon, suppose 1, Again, there will be this, and further this carbon. So it will be a giant structure. Carbon. I'm using different pans, color of pan, so that there will be a kind of clarity. Yes, now understand how diamond is good conductor of heat. So basically, for good conductor of heat, we require a continuous flow. We require only one requirement is there, continuous. There should be a continuous flow. So it will be good conductor of heat if there is continuous flow. So let's suppose if I'm going to heat this carbon, right? So if I'm talking about a metallic bar, suppose this is your iron, and you are suppose you are having a steel spoon. That's very easy to understand. And this steel spoon you are placing in the hot coffee mug. Okay, after some time this spoon will also get heated. Why? Because the steel is made up of iron, right? Alloy of the iron and carbon. So the iron atoms are transferring the heat due to the continuous structure. Similarly, what will happen if it is good conductor of heat? So there will be continuous transfer of heat. So this will heat it up. This will also heat it up because it is a neighbor atom. Again, heat will be like this, transferring from this to this, and there will be a continuous channel, and the whole diamond will be heated up. Are we getting this? So this is how we can explain according to the structure how diamond is good conductor of heat. If I talk about electricity, conductor of electricity, so the requirement is movement of free electrons. Movement of free electrons or ions. Okay. So in the covalent compound, we cannot imagine the presence of ions, but yes, there can be possibility of movement of free electrons. So let's check. So basically I have written here carbon is attached to the 4 further carbons. Carbon has a valency equal to 4. So carbon is supposed to make 4 bonds only. So here if carbon is already engaged with 4 other carbons in the structure of diamond, so is there any possibility of getting the free electrons? No, of course. So basically all the electrons are utilized in forming the covalent bond to the next neighbor carbon. So there is no presence of free electrons. So there will be no movement of electron, and it is considered to be bad conductor of electricity. Are we good? So basically this can be important for you. Now, proceeding with the uses. What can be the uses? So basically diamond is used in the cutting instrument like glass cutter and in the rock drilling equipment. Why? Because it is hardest. It is hardest. So we can use this strength in the cutting hardest other hard substances. Also, it has sharp edges. Sharp edges. Good? Okay. My dear students, next use is diamonds are used for making jewelry. Why? Because of its extraordinary brilliance. And it's precious also. Sharp edges diamonds are used by the eye surgeon as a tool to remove the cataract from the eyes. Again, I told you because they are having the sharp edges, so we can use it in the surgical methods also. Good. Okay. Now we have the graphite. Okay. So graphite, as I told you, diamond is hardest. Why hardest? Because diamond has a case-like structure. Diamond has a rigid structure. We already have discussed why diamond is hard. Let me write it for you. Hardness. Reason for hardness. Now, let's discuss what is graphite. Let me show you first. So graphite is originated from graphene. Graphene means to draw or to write. So graphite, due to its marking ability, we use it in the pencils. We are marking it from, from the pencils or etc. So that is containing graphite. Now graphite occurs in the free state, but is it also prepared artificially? We can also prepare it according to our use. Now it is grayish black opaque substance. Unlike carbon, it is what? Grayish black opaque substance and lighter in diamond, soft, slippery to touch. It's important to highlight soft and slippery to touch. Why? So next, it is good conductor of electricity and bad conductor of heat. Okay, and bad conductor of heat. Now again, if I talk about why graphite is soft, why soft? So let's check out the structure. We will zoom it, we will check it out what is happening inside the structure of graphite. So why it is soft? Because one carbon is attached to further. I'm not sure how many carbons, so I will let you know if I'm talking about this carbon. So you need to check how many carbons are attached with this carbon. So one this carbon and this carbon. I will show you with another figure. Now you can count it very clearly. Suppose this is one carbon, second, third, fourth. So this, if I'm counting from this carbon, so this carbon, this darkened carbon is attached to further 3 carbon, and this is the kind of structure diamond is forming. What kind of structure? Let me write it here. 3 carbons forming hexagonal rings. Hexagonal rings. So I hope you are not afraid of this hexagonal, because you can clearly see in the mathematics we have something structures like these: hexagonal, pentagonal, octagonal, etc, etc. So you can clearly see there is big difference in the structural unit of a diamond and a graphite. So next point is, now these hexagonal rings are arranged in the layer structure. What structure? Layered structure. So suppose this is your hexagonal ring. Okay, let me form one another layer. Okay, and this is a huge giant structure. So suppose this is your first layer. You can understand it likewise, and this will be like this. So they are kind of layered structures. So if I'm talking about the layer structure, so it will be very easy to slide over each other, glide over each other. Yes or no? So there is no rigidness in the structure. That's why it is soft and slippery to touch. So here I can clearly write that forming hexagonal ring and a layered structure. Layered structure. Okay, structure. So you can clearly see this is your one layer, layer 1. This is your another layer, green color of layer 2. This is your third layer. So you can imagine there can be a number of layers in making the graphite. That's why it is soft, slippery to touch. Are we getting this point? Why diamond is hard and the graphite is soft? Because of their arrangement of atom in their structures. Now, one another thing I would like to explain here, why it is good conductor of electricity. So as I told you, for electricity, for conduction of electricity, we require free electrons. And I can clearly see that carbon, one carbon is attached to further 3 carbon, and carbon is supposed to form 4 bonds. So where is the extra electron? So every single time I can clearly see, suppose this is bond 1, sharing, sharing, sharing. So this extra electron, 1, 2, 3 and 4 carbons. So, sorry, 4 electrons. So one extra electron is always left to move freely. And that's why it is considered to be a good conductor of electricity. In this class, you can satisfy with this explanation. Now, if I talk about the conduction of heat, why bad conductor of heat? So basically, you can understand for conduction of heat, we require a continuous channel. But here we have the layered structure. So that's why bad conductor. Bad conductor of heat. And only 3 electrons. So basically 1 free electron. So it will be good conductor of electricity. Are we good? Okay. So I hope this is very much clear to one and all. Now uses, where we are using the graphite. So basically very first use, you can clearly see that graphite can be used for lubrication. Lubricating those machine parts which are operating at the high temperature. So basically why lubrication? Lubrication is something like oiling or greasing huge machine. Because they are working and they get jammed. So basically we are oiling them. So because the graphite has a slippery or the soft touch, so it can provide you the lubrication. Done? So we are using it as a lubricating agent, and graphite is used for making graphite electrodes in the dry cell. In the higher classes you will get to know about the cells. Okay, dry cell, fuel cell, etc. and etc. Also, we have done the electrolysis of water, right? Brine. So, what we have done? We got the electrodes. So, these electrodes are made up of graphite because of good conductor of electricity. Now, graphite is used for making the cores of the pencil. In the exam, you are supposed to take the pencil with you. So, that's also the one of the use of graphite. Now, let's discuss fullerene. So, here you can see this Mr. His name is Richard Buckminster Fuller. So, he was not the who discovered fullerene, but yes, he was an architect who made the geodesic domes like this, and in order to give him tribute, we call the fullerene as Buckminster fullerene. So basically until 1918 we had only 2 allotropic form of carbon. Then we have British chemists like Croto, Smellie and the Curl who discovered fullerene by using pulsed laser vaporizing graphite rods. This is not important how we prepared them, but yes, it is important that we have another allotropic form now. Now, C60 was the very first stable giant fullerene. Carbon 60, that means carbon up to 60 atoms, they are joined together. So, it was named after the honor of Richard Buckminster Fuller, who was an architect right? And the shortened name fullerene was referred to tribute this to Mr. Richard. Are we good? Now, so basically, how can we understand the structure of fullerene? So the structure is kind of a soccer ball, right? And it is spherical shape and can be made using 12 pentagonals and 20 hexagonal. Basically, Buckminster Fuller, this fullerene is something like, seems like the structure of the geodesic domes prepared by the Sir Richard's Buckminster Fuller. So basically we are deriving the name from there only. But if I talk about the actual structure, it seems like a soccer ball also. And here we can see there will be pentagons. This is your pentagon and a hexagon. How many pentagons? There will be 12 pentagons and 20 hexagons. All together will form a structure like soccer ball, right? And will be giving the structure to the fullerene. And each pentagon is surrounded by 5 hexagons. No 2 pentagons are adjacent. In the higher classes, you will get to know the structure in detail. But right now, there are a few important points that you need to understand. Okay. Now, here you can see the pentagon and the hexagons. Let me show you. 1, 2, 3, 4, 5 and 6. So, it's a kind of hexagon. Right? If I talk about any pentagon, so it is kind of here. Yes? Now, let's discuss the uses. So, basically, fullerene is used for the antioxidant and biopharmaceuticals like your skincare, cream, etc. etc. Next, we have the catalyst. That means they increase the rate of reaction. Okay, so there are some chemical, there are some chemicals which do not involve in the reaction, but yes, definitely alter the rate or the speed of reaction. Water purification, biohazard protection vehicles, right? We are using them in order to enhance the efficiency of the vehicles. We are using fullerene there. Now, very important question. Why carbon is versatile in nature? So let me tell you, my dear student, what is versatile? That means having many qualities. Suppose in your class there is a guy who can sing well, dance well, always top the class, a sincere one. So basically many qualities in single boy. So you can call that boy as a versatile guy. So basically, do you know any guy or the girl kind of having this kind of characters? Now, why does carbon form number of compound? Of course. So you need to answer this question because many time in your board examination, the examiner has asked you this. So we have the 4 major characters to explain this. So this is your carbon right now. Okay, you can laugh right now. Why? Because carbon is so versatile. Now, why? Answer is because it has tetravalency, because it can show catenation, because it can form multiple bonds, and because it is forming or showing the concept of isomerism. Done. So, basically, we will discuss these one by one. So, very first, we are going to deal with tetravalency. So don't get afraid, take a deep breath. Okay, we are going into this chapter more and more. So tetra means 4, tetra means 4 and valency means combining capacity. Combining capacity. So carbon has a unique electronic configuration as I have told you, having 4 electrons in the outermost shell. So carbon has a valency equal to 4. Here you can see this octopus having 4 arms or the legs, 1, 2, 3 and 4. You can imagine it's the carbon only. It is capable of bonding with 4 other atoms of carbon or the atom of some other monovalent atoms. What that means, monovalent? Mono means 1. Valent means valency. Such as your hydrogen, can be your chlorine, fluorine, bromine or iodine, etc. etc. Are we done? So this is your tetravalency. Why carbon is showing the tetravalency? Because carbon has 4 electrons in its outermost shell. These 4 electrons. Are we good? So basically, carbon neither lose nor gain 4 electron in order to complete its duplet or octet. It shares these electrons and form covalent bonding up to 4 atoms. With 4 atoms. So that's why we can say, and these tetra or you can say 4 bonds are very stable. We will know why. Before that, we are going to understand what is catenation. So catenation is something like self-loving, self-linking, self-linking. If you are not having any kind of friend, you can be your own friend. You can tap your shoulder. You can be proud of yourself. Similar, how carbon is doing so. So carbon is having a great property of self-linking. It is appreciating itself and making bond with itself. Carbon, 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 and long chain of carbon. So basically, you can see self-love, the property of self-linking of carbon atom through the covalent bond. Always remember, carbon forms bond which is known as covalent bond because of sharing of electron. So carbon through a covalent bond to form long, straight and branch chain rings of different sizes is called catenation. So it seems like a big definition, but catenation means self-linking. By self-linking, it is forming different kind of structure like the linear chain, like the branch chain or the ring structure. So basically why? The reason is why? Because of small size. Small size of carbon. Suppose this is your carbon 1, this is your carbon 2 and making a bond. Carbon-carbon bond. Okay. Now, I'm just showing you how carbon is making bond with carbon itself. Not, suppose they are the hydrogens. Okay. That will help you. So, carbon is having smaller size. Now, how it can be an advantage? So, basically, if the carbon is having small size, so the bond that is formed between those two carbon, that will be also small. Yes, and you can say that the nucleus hold more power, nucleus hold shared electrons more tightly. Tightly, these shared electrons means the covalent bond. Suppose this bond is formed by the sharing of this electron and this electron of the carbon. Yes. Now suppose the nucleus is holding the shared electron with more tight force. So this bond is going to be stronger. Yes or no? Of course. Okay. So we are going, giving them more importance because they are having a short bond. Now if I talk about there are any other element which can also show catenation, so your answer will be yes ma'am, or your answer should be yes ma'am. So it's your silicon. Silicon in the periodic table, if you see, this is your carbon, it will be your silicon. So carbon and silicon belongs to the same family. While carbon being smaller in size shows catenation on the large scale. But because silicon is larger in size, so its bond will be also larger and there will be no more hold on the shared electron and then the bond will not be that strong. Not stable, not existing. So simple, silicon up to 7-8 atoms shows the catenation. I have told you the reason why. Alright. Now, you can see the branch chain structure. First, you need to understand a linear straight chain. Simple. Carbon, 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 carbon in the straight line. Just like in your assembly you are standing. Okay. Now, what about the branched chain? So, basically, have you seen the tree? Have you seen the tree? Yes. So there will be a stem and then branches all over. So I can show you like this. So this is the stem. So basically this is your linear chain. And other than this linear chain, the parent chain, there are some other carbons attached. We call them branches. We call them branches. And the compound is known as branched compound. Yes or no? Okay. And if I talk about one carbon is attached to the, you can say the very first carbon attached to the terminal carbon. So it will be forming a cycle. Yes. So it will be forming a cycle or a ring. Done. So very short ring, or you can the smallest ring a carbon can form, that will be using the union of 3 carbon, 1, 2, 3, and it will be a trigonal ring. Then we have the pentagonal ring. You can also have the hexagonal, octagonal, and so on. Okay, we do these structures in the maths also. And now let's discuss the another property, tendency to form multiple bonds. What is that? Multiple bonds. So multiple bond will be carbon-carbon single bond. That's your single bond. Carbon-carbon double bond. Of course, it is your multiple bond. Carbon-carbon triple bond. Okay. So we are going to discuss these cases. Okay. This is your single bond, double and triple. We call these as multiple bond. Multiple. More than one. So let's discuss the property of self-linking. Okay, again it is about catenation. Yes, of course, due to catenation, carbon comes closer to the carbon, and we also understand why this is happening, why this catenation in carbon is occurring on a large scale. Size issue, and the hold of shared electron by the nucleus is higher. Now, what about this multiple bond? So, carbon form carbon-carbon single bond, carbon-carbon double bond, carbon-carbon triple bond. In case of carbon-carbon single bond, sharing of 2 electrons occurs, sharing of 4 electrons occur, and sharing of 6 electrons occur. This can be the maximum number of electrons one carbon can share with the another carbon. Are we done? So basically we call them single bond. Okay, we call it saturated compounds, saturated, and this case is known as unsaturated compounds. Now you will be like new terms, more new terms. Yes, so we are going to understand if the carbon is forming the multiple bond with the carbon, what kind of compound they are going to form. Again, the bonding is going to be covalent only, sharing, but single, S4 single, S4 saturated. Otherwise, you can learn unsaturated means double or triple bonded carbon compounds. Now, isomerism. So basically, you can learn this like wise. Isomers. Iso stand for same. Mers means you can call it chemical formula. Okay, I will write it in the simplest form. Same chemical formula but different arrangement of atoms. So similarly, you can simply say this, that the chemical formula is same, but there is arrangement. There can be different arrangements. Suppose you are having 6 of your friends, so you can also form a hexagonal. You can also form a single line. So you can see different kind of structural arrangement you can form. But the number of students, the number of friends are 6 only. Yes, so in the case of carbon, carbon forms a large number of compounds. So it has a property of isomerism, same chemical formula. For example, you have C5H12. Okay, we will name it later, but I would like to show you their structures. So I can write it like this: carbon, 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 and carbon. So carbon is forming 4 bond always and forever. Always and forever. So if I have formed only 1 bond with this carbon, 3 bonds will be formed by hydrogen. Yes, again 2 bonds will be formed by hydrogen. 1, 2 clear, 3, 4 more clear. 1, 2 clear, 3, 4 more clear. Now we got the straight chain structure. Done. I can also write it like this. Carbon, 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 carbon and carbon. Okay, now it's the time to fill all the valency of carbon. So here I can write hydrogen, 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 hydrogen and hydrogen. Are we good? Are we good? Okay. So you can see this structure is different from this structure, and then we can also have one more structure which I can write it like this. Carbon, 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 carbon. Okay. It's a kind of your crossover on the roads. Can you count the number of hydrogen and carbon for me? It will be carbon 5 and hydrogen 12, but the arrangement is different. So basically all these three are isomer to each other, and this property is known as isomerism. Okay, so many carbon compound form such kind of isomerism, can show such kind of isomerism. Now we have the topic of hydrocarbon. So carbon is very much compatible with hydrogen and forms a large number of compounds. Okay, carbon hydrogens are like best friends, like Na and Cl. Whenever we talk about ionic compound, the very first example is sodium chloride. Sodium and chloride, most loving species, right? Now, similarly, carbon, we have the hydrogen, the best friend. So carbon and hydrogen together form a large number of compounds, such that we need another chemistry. We name it like organic chemistry. Now, so we call it hydrocarbon. Hydro stands for hydrogen and carbon stands for carbon. Carbon and hydrogen collectively form n number of compounds, and we call these compounds as hydrocarbon. Done. The hydrocarbons are studied in the different chemistry. We call it organic chemistry. Organic. Yes. In the higher classes, there will be, in fact, in the class 11th, you will be dealing with three kind of chemistry: organic, inorganic and physical. Not important right now, but yes. Now, organic word came from organism. So, earlier it was assumed that, it's an interesting story. Earlier, like Bergelius said that the organic compounds, the hydrocarbons, cannot be formed in the laboratory. They can be derived from the vital force, and that is contained by the living organism only. Organism, organic compound. Okay, so we require living organism in order to have the organic compound. But then we got another scientist, and who actually challenges the vital force theory and formed the very first inorganic compound in the laboratory, named as urea, from the ammonium cyanide. So basically that is a kind of story when we are discussing the origin of organic compounds, hydrocarbons. Okay, not important from your board point of view. Now, a large class of chemical compound in which more carbon and covalently linked to the atom of other element, commonly like hydrogen, oxygen or the nitrogen. So we are going to discuss hydrocarbons that also contain not only hydrogen. Carbon can covalent bonded, carbon can form the covalent bond with hydrogen, best friends, best buddies, but sometimes this poor hydrogen is not available or got substituted by oxygen, nitrogen, chlorine, etc., etc. Okay, now saturated hydrocarbon, as I told you, because carbon has a capacity to form multiple bond with itself. Huge power, it takes huge power to, self-linking, making the multiple bond with itself. So basically we have the saturated compound. So what are these saturated? Saturated, S stands for the carbon-carbon single bond. It's way clear. So suppose we have C, H, carbon-carbon. I repeat, carbon-carbon. Sometimes students get confused why carbon is also forming bond with hydrogen, a single bond. We are not counting that. My dear, we are not counting that. Whatever the bond carbon is forming with any other element, we are going to discuss only carbon-carbon bond. Okay? So if you see carbon-carbon single bond is there, so you will call it carbon-carbon single bond. I repeat, carbon-carbon single bond. Okay, so we call it saturated compound. Done? Now, unsaturated means carbon is forming multiple bond with the carbon. So we will be having two cases, carbon double bond carbon and carbon triple bond carbon. Okay, now I would like to ask you one thing. If carbon has formed double bond with another carbon, so how many bonds are still remaining? Let me know for each carbon. Is your answer 2 in this case? Yes, and 2 in this case. So carbon 1, 2, 3, 4. 4 bonds are formed. It's a stable. Hydrogen will always form only single bond. Here also you can see carbon is forming 3 bonds. This carbon 3 bond. So there will be 1 bond like this. Hydrogen 4 bonds completed. Then you have this carbon. There is requirement of 1 hydrogen. Are we good? All right, then great. So if I talk about this, let me know in the comment section, what is it? And this, what is the basic difference between these two? Do let me know in the comments. Fast, what is the basic difference between these two? Which one is saturated and which one is unsaturated? So basically I can clearly see you need to put a carbon here. On each vertex you can write it like this. Similarly on this case, so you can see here carbon-carbon double bond is present. Then single, then double. Single and double. So it is a kind of unsaturated compound. Unsaturated. And you are going to call it as benzene. Unsaturated cyclic compound because forming a cycle, a ring. Also if I talk about this is saturated. Simple saturated. Okay, saturated cyclic compound, I can call it cyclohexane. And these both are having different properties because both are from the different kind of compound, unsaturated, saturated. Are we done? Alright then. So next we have the hydrocarbon. Let me show you. Saturated single carbon-carbon bond containing compounds, multiple carbon-carbon bond containing compounds. Single saturated are also have the class of alkanes. Alkanes. I would like you to repeat after me. Saturated single carbon containing single bond, single carbon-carbon bond containing compounds, and we call them alkanes. General formula for alkanes is CnH2n plus 2. CnH2n plus 2. What is N? N can be the number 1, 2, 3 and so on. So if I place N is equal to 1, So C1H2 into 1 plus 2, and it will be forming the very first alkane, which is your methane. Have you ever heard about methane? Yes or no? The marsh gas, methane, right? CH4. Now, let's discuss about the unsaturated compounds. There are two classes. One is the alkene, doubly bonded, carbon-carbon doubly bonded, and alkyne, carbon-carbon triple bonded compounds. Now, suppose what can be the general formula? It will be having a general formula CnH2n. No plus, no minus. Okay, so basically, my dear students, for alkene, we have a general formula CnH2n, balanced. So, N has a value of, starts from 2 only. Why? Because if you are placing, if you are, if you are holding this pen with me, so one hand is required and there will be requirement of other hand from your side. So, basically, similarly, if I am talking about this double bond, in order to carry this double bond, we require 2 carbon at least, right? So, N value minimum can be equal to 2. Maximum, anything, any number. So, C2H2 into 2, which is C2H4. We will also name them later, but right now it's okay. Now, alkyne, carbon-carbon triple bond. So, you can also write it here, N is equal to, what can be the formula? It will be CnH2n minus 2. Alkane, CnH2n plus 2. Again, CnH2n. Alkyne, CnH2n minus 2. Okay, so suppose if I am writing C5H12. Can you tell me it's alkane, alkene or alkyne? I will give you one trick. One trick. Simple. 5 2 ja 10. 10 plus 2. So plus 2 plus 2, that's alkene. Alkane. Okay. Suppose if I am writing C4H8. 4 2 ja 8. No plus, no minus. Multiple of 4. Multiple of N. That is your alkene. Right? If I'm going to write C2H2, what can be that? What can be that? What can be that? So, I will be writing here N is equal to 2. Let's make it 2. 2 into 2 minus 2, which is C2H2. Equal number, right? 2 into 2 is equal to 2. It can be C4H8, it can be, okay, it's already done, C6H12. What is it? What is it? Do let me know in the comments. Now, we already have discussed that the saturated compound have the class of alkane. The formula is CnH2n plus 2. Now, unsaturated compound, the multiple bonded carbon compound, we have alkene and the class of alkyne. The general formula is way important. Now, jumping to the functional groups. So, as a name suggests, functional means something related to work potential. Function. How do you function? If I am going to ask you, how do you function? That means how do you working? So, functional groups are the group of atom that is going to attach with the carbon chain that we have already discussed. So, attached to the carbon chain because they are neither hydrogen and nor the carbon, some other atom. So, we call them heteroatom or group of heteroatom, right? So, they are attached to the carbon chain and show or determine the working, the function of the whole compound. So, basically, the functional group may be defined as heteroatom other than any atom which is other than carbon or hydrogen, or the group of heteroatom present in the molecule which largely determine its chemical property or its function or the work potential. Done? Okay. So in our book, we don't have a large number of functional group. In higher classes, yes, we have a number of functional group, but right now in the class 10, we have to deal with halogens. So halogens means the halide group, fluorine, chlorine, bromine and iodine. So you can see, if they are attached to the carbon and hydrogen chain, that means the hydrocarbon, they are the heteroatom. Okay, so you have to name them with politeness, with gentle speaking. You can call them fluorine to fluoro. You will call it, my dear fluoro. Fluoro. You will call it chloro. Hi chloro. Not bromine. Hi bromo. And this is hi Ido. How you doing? Now, we have the alcohols, the large, kind of compounds, ethanol. We know it well. So, you can see the alcohols. So, what can be the, how can we detect whether the compound is containing alcohol or not? So, the group carbon, CH3, CH2 will be containing OH group. So, we can identify, this is the group of heteroatom. Now, you will be saying, ma'am, hydrogen is always attached to carbon, but no, this time it is not attached to carbon but oxygen. It is coming from the oxygen side, right? So, it is the group of heteroatom. Now, we will name it like, it is the alcohol group, yes. So, in the nomenclature, we will be using all, right? We will be using all for indicating the compound is having alcohol unit. Good? Are we good? Alright. Then we have the aldehydes. Okay. So, aldehydes can be written as CHO, like CH3, CH2, CHO. This is your aldehyde, right? You can also write it like all CH3, CH2, COH. Don't get confused. Sometimes student gets confused with the structure of CHO or the COOH, right? So you can clearly see here, this is the CH group, here the hydrogen group, and oxygen is doubly bonded. So we call it the aldehyde group, and we name it like aldehyde. So how can you name it? You have to steal L from aldehyde. Are we good? L from aldehyde. In the case of alcohol, we are going to steal all from the alcohol. Done. Next we have the ketones. So ketones are nothing but CH3, CO, CH3. Right? So you can see the antenna-like structure. The oxygen is on the head of the carbon. You can see no hydrogen this side or that side. Okay, only single bond. Done. So we call it ketone. Ketone. And in order to name it, we will be stealing on from the ketone. Okay, you have to name them. You have to write them in your rough notebook or the register. Once you have written everything, it's my guarantee you are not going to forget it ever and forever. Now, last but not the least, we have the carboxylic acid group. Okay, so suppose we have CH3, COOH. I have seen this. Now, how can I name it? So, I can write it like carboxylic, 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 carboxylic acid. Okay. Now, how can I name it? I will be stealing oic acid. Oic acid. Done. Now, most important thing I would highlight here. These CH3, CH2, long chain of carbon and hydrogen. Long chain of carbon, or you can say the hydrocarbon. You can represent it by R. Yes, really? Yes, of course. You can represent it by R only. So if I want to write this, so it can be written as ROH. CH3, CH2 all together I have written as R. R means there is some hydrocarbon, carbon and hydrogen only. Now if I want to write this, so I can write this R. If I want to write this, this will be R, this will be R, not this. Then if I want to write this, so I will be writing this R only, not this. Because carbon is attached to the oxygen and then hydrogen. Right? Now many students get confused here also. So carboxylic acid can be written as this also. COOH. Both are same. Done? Of course. So here we have the homologous series. First we understood the functional groups. Functional groups are the heteroatom or group of heteroatom which are attached to the normal hydrocarbon and then change their function. Determine their potential, work potential. Right? So similarly, I have told you all are R. This is R. This was R. But the functional group is different. So their function will also be different. Now, homologous series. Homo means homologous. Homo, same. You can also consider logos as unit. Same unit, difference. That is equal to CH2 unit. Now, what is this definition? Basically, homologous series is a kind of series of compounds. Series of compounds having a common difference between the consecutive compound. Suppose I have CH4. I have alkane series. CH4, C2, H6. Okay. I have C3, H8. I have C4, H10. Now, I want to check the difference between the consecutive atoms, compounds. Here, minus this, so it will be 1 carbon extra, 2 hydrogen extra. CH2 unit, difference of CH2 unit. Next, these two. So, this is the higher one, this is the lower one. So, I will subtract and will be getting CH2 unit again CH2 unit. So, the difference is common between the two consecutive compounds in a series of compounds. So we can call it as a homologous series. Okay, if I want to ask you, what can I write here? The fifth member of the family. What can you write? What can you write? Just add CH2 unit into it. Yes, it will be C5H12. C5H12. Right? If I want to check the difference, it will be CH2 unit and it is showing a homologous series. Are we done? Okay. I will give you one homework. Of course. Member of a series can be represented by the same general formula. How is it possible? Suppose I have alcohol. I have CH3, CH2, OH. Now, I can write it like this C2H2N plus 2O. This can be the general formula for what? Alcohol family. I can place the number of N every single time and will be forming N number of compound, and interestingly, they will be having, okay. So, I will be having N number of compound, I will be placing the value of N, will be having N number of alcoholic compound and will be having the difference that is equal to CH2 unit. Are we done? Okay. So, if I want to ask you one question, suppose this is your CH3, COH, we have next CH3, CH2, COH. I want to know the next member of this family, whether they are homologous or not. Okay, now another question. This is your question 1. I'm giving you question number 2, which is CH4, C2H. Okay, this happened before. C8H16, C9H18, C11H22. Do let me know whether these are under the homologous series or not. Are we good? Here you need to tell me the member, the chemical compound that is going to be arranged here, that is going to be suited here. And number 2, you need to tell me whether this is a homologous series or not. And if it is a homologous series, so what kind of series? Alkane, alkene, alkyne, or whatever. Now, let's discuss for more points. Members show a gradation in the physical property. Of course, if the hydrocarbon chain is getting longer and longer and longer, so it will affect the melting, boiling point, the solubility, which are the physical properties. Done. Now, members have the similar chemical property. Of course, they belongs to the same family, compound or family, right? If you are having the same surname, so you are going to belong the same family. So chemical property is going to same. Your ethics, your culture will be same if you are dealing with the same surname, same family. But your age, your height, your weight will change. Physical properties will not remain same. IUPAC, okay, right? Many students are very afraid of this IUPAC. What is this? IUPAC stands for International Union for Pure and Applied Chemistry. It is a kind of worldwide organization which was established in this year. Not that important. I just want to make you understand that we are bound with some rule and regulation in order to name the organic compounds. We cannot form anything from our heart. Yes. So, its a main purpose to aid the chemical sciences as well as their application with humankind organic nomenclature. A large focus of IUPAC was established in 1892 when the chemists created a list of rules called the Geneva Rules. There are some list of rules, right? These groups of chemists ultimately became IUPAC, and who is we should thank for organic nomenclature. Suppose carbon is forming millions of compound, right? And you got a book and you need to recall all the names. Can you imagine the situation? It will be the toughest one. But as we know the rule to name any compound, so we need not to recall any name. We can make it all of a sudden. Yes or no? So basically sometimes student ask the question, why can't we do this? Why can't we name this? Because we have the set of rules and we need to follow them. Okay, now we are going to understand these. Rule number 1. In the higher classes, of course, there are many rules because the complexity is higher. But in your class, we are going to deal with a few rules. So one is the identify the parent chain, right? So basically, suppose we have CH, carbon, 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 carbon. Okay. The rest bonds are satisfied by hydrogen, of course. Where there is no one, there is hydrogen. In the case of carbon only. Okay, now I have the another compound, suppose this, right? So if I want to, I want you to name this compound. So what can be the largest? Suppose, okay, let me draw this again. So it will be okay. Let me write the hydrogens everywhere. So you need to find out the longest chain. So there are two, compounds, 1 and 2. Can you tell me A and B? Out of these, which one is having the larger chain and how, where? So basically I can see this is a simple straight chain, 1, 2, 3, 4, 5, 6. Done. 6 carbons are there. If I talk about this, so it is having 1, 2, 3, 4, 5, 6. 6 carbons. But if I can, count 1, 2, 3, 4, 5, 6 and 7. So it's not a straight chain, but of course we are not dealing with the straight or the branch chain. We are dealing with the largest parent chain. So this will be my largest parent chain. Also you can count it like this also. But it contains only 4 carbons, so it's not a larger one. So what can we do? We can name it now. So first rule is clear to you? First rule is clear? Okay. Now I would like to tell you few more rules. One is suppose we have the prefix, we have the word root, we have the suffix. I will give you one example. You need to understand that very well and that will help you. Suppose I am writing Ram, Lal, okay, Ram Singh. Suppose Ramesh Singh, Mr. If I am writing this, is it a correct way to write any name? Am I correct or not? You will be saying, no ma'am, we can write it like Mr. Ramesh Singh. So basically, you can clearly see Mr. is representing something, right? Mr., Master, Miss, Mrs., etc. So that is always a prefix that comes before the name. So basically, this is your prefix. Prefix comes before name, which is your Mr. Then next we have Ramesh. So Ramesh is the actual name of the person. So we will be writing that name just after Mr. So that's your Ramesh. And I will call it as word root. Okay, the real name. Next we have the Singh. What is that? Singh is the surname and that comes after your real name. Like Rahul Khurana, right? Manish Kumar, etc., etc. So basically what is happening here, we can write it like this. So Singh is the surname, that is your suffix. Are we good? That's your suffix, so I can write it here only. Now I would like to ask you whether I have corrected this name or not. Your answer will be yes. So in the English also, not only in the chemistry, in the English also we have some set of rules and we need to follow them. Now I hope this is clear. So basically, similarly in the organic compound we have some prefixes, we have some word root and suffixes. So let me write it for you. Prefix. There are two kind of prefix. One is your primary. This is one of your important slide. Primary, and the other is your secondary. Again, you have the suffix. Suffix is also primary and secondary. Primary and secondary. So, let's have this primary prefix contains cyclo. Shows you whether the compound is cyclic or not. Suppose you are having a cyclic compound. I have written cyclohexane. So cyclo means it is having a cyclic structure. Done. So basically, primary consists of only the information whether the compound is cyclic or not. If not, you need not to mention anything. If it is cyclic, you have to mention cyclo. Done. Also, we have the CH3. C2H5, etc. group, we call it alkyl group. What we call it? Alkyl group. When you name it alkyl, so this "yl" is attached to number of carbon. So number of carbon is 1, so it will be methyl. Number of carbon is 2, it will be ethyl, and so on. Right? We use them in the branch section. The common or the parent chain will be containing number of carbon. We will be using them in the word root. In the branch section, we will be using ethyl, methyl, propyl, butyl, etc. I'll give you the examples. Don't worry. Then the secondary prefix have halogens. Such as fluorine. You are going to call it fluoro. Bromo, ido, chloro, then etc. Then we have the word root, very important, and I hope every one of you know that. If you are having the carbon, single carbon, you will be naming it as meth. Carbon number 2, eth. Carbon number 3, carbon, it will be prop. Carbon 4, but. Carbon 5, pent. Carbon 6, hex. Carbon 7, hept. Carbon 8, oct. Carbon 9, non, and carbon 10, dec. It is enough. Up to 7 and 8, it is all enough. Now, primary suffix. If the carbon is single bonded, you need to name it as ane. Carbon is doubly bonded, you need to name it as ene. Carbon triple bonded, you need to name as ine. Now, one important thing I would like to mention here. This ene is the master, right? If the carbon is containing single and double bond, so you will not be writing ane and ene both together. You will be writing only ene, because ane is the common now. Ene is the fancy. So we will be using ene over ane. If there is carbon triple bond, so you can mention ene and ine both together. Now, we are going to have the secondary suffix, which is your functional groups such as alcohol, such as your aldehyde, your carboxylic acid and ketones. Carboxylic acid. Done. Let me write the functional groups for you. All indication is presence of OH, CHO, carbon double bond, the antenna side, both side will be R group. Oic acid you will be using at COOH. What are you going to mention there? For OH it will be ol. For CHO it will be al. For antenna oxygen that will be on, and for carboxylic acid it will be oic acid. Are we done? Now rule number 2. Before rule number 2, I would like to name or practice some compounds like 1 CH3, CH2, CH2, and this is your CH3. Can you name it? It's the simplest one. Check it out with the rule, prefix, word root. Always write it. Whenever you are naming, just write it. For a few days only, and then you will be getting the practice. You will check whether prefix is present. No prefix. No primary. No secondary. Now, prefix is cut. Word root, yes. Carbon, 4 carbon. That means but. Now, suffix. Jump to the suffix. Don't get hurry. Keep in your status of rules. Yes, so we are going to have primary suffix. Single bonded ane, butane. That's your name. Now, secondary suffix not present. No worries, no worries. Now, let's discuss. Suppose we have another question, number 2. CH3, CH, double bond, CH, CH2, Cl. Done. Now, check this out. Rule number 1. We have only one chain. That's the straight chain. Okay. So, basically, here I can see prefix. Yes. I have the, then we have the word root. Then we have the suffix. Which suffix? Primary suffix. Okay. That's all inside my brain. Now, I can name it. Prefix, that is your chloro. Okay. You can also number it. Number it means you can number it. I will show you when we are going to discuss rule number 2. Okay. So, chloro. Now, prefix is over. Come to the word root. 1, 2, 3, 4. That's your but. Done. Don't place ane. Check. We have ene, double bond. Double bond is superior. So, we will be writing ene. Done. Chloro, butane. Done. Now, the problem is we are not indicating the location of double bond. Suppose you are going somewhere else. Okay. You are at your home and your friend is calling you from somewhere else and he is not giving you the address. Where to come? How to come? So, are you able to go? Will you be able to go? Your answer is no. You will be requiring something to reach over there. Similarly, if you are not indicating the location of the double bond, then how can you write butane only? If you are not mentioning anything, so it is assumed that this butane is at carbon number 1. Okay, carbon number 1. We are not mentioning anything at number 1. 2, 3, 4, 5, 6. Okay, because 1 is understood. 1 is understood. Now, let's suppose we have another question. Suppose we have question number 3. Done. CH3, CH2, CHCl, CH3, CHCl, CH3. Now we need to name this question. Okay, we need to name this question. For this we require, already there is no confusion for the, checking the parent chain. There is only one chain, which is a straight one. Okay, so now we have one Cl here, one Cl there. How to name this? How to number this? So we will be using rule number 2. Lowest locant rule. Now what is this locant are? Locant is nothing but the number. Okay. Now suppose you have the 3 friends. You have 3 friends. A, B, C. And you are in the trouble. You are in the trouble. We always have a number of friends, the best friends, but only one can be the closest to our heart. That's true? Yes or no? Give me a thumbs up if you are agree to this point. Now, suppose you are in the trouble. So, you will be calling to B first because you have greater connection, suppose. Then, you suppose out of A and C, to whom I should call? Okay, A. A is better. Now, of course, C is going to get this thing from either of the people. So, let's call him also. So, there is a preference. You gave number 1 to B. Preference. So, just let me know whether number A, 1 or 3. Which one is the lowest? You will say number 1 is the greatest. No. If I am talking about 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 is the largest. 1 is the smallest. Okay. So, your preference is given to B, which is the lowest number. Give the lowest number to your favorite one. So, the functional groups, the prefix or the suffix, whatever kind of functional group we are going to have, You have to give them the lowest number possible, lowest possible number. So now we have the ClCl, both are coming from the prefix side. Okay, both are coming from the prefix side. What if I'm going to have a question like this? What if I'm going to have a question like this? CH3, CH2, CH, OH, CH2, CH, Cl, CH3. Done? Okay. I'll be doing this question. Before that, let's discuss this. So here is the scene. Both are the prefix. I can name it from here 1, 2, 3, 4, 5. I don't know what is the best possible way. I'm just writing the number only. Alright. Okay. So next is my point of view. I can also write it from here 1, 2, 3, 4, 5. What is the next step? You just have to add these numbers. Here according to 3, we have the Cl. Here we have on 4 Cl. 3 plus 4, number 7. Okay, I'm using the different pen to make the clarity. Okay, here you can see, my dear student, we have Cl at 2. We have Cl at 3. 2 plus 3, that is 5. Let me know which number is lowest. 5 or 7? 7 is highest and 5 is the lowest number. So I am not going to consider this. Cross, 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 cross. Alright, you will be having the pencil, you can erase it. Now, what can be the name? I will be taking this number. So we have 2, 3 dichloro. What is it, dichloro? Okay, suppose you are going to watch the movie Judwa or any other twin movie. So if I talk about Judwa movie, because I know the character that was played by Varun Dhawan. So if your friend is asking who is in the movie Judwa 2, so you will be saying Varun Dhawan in the double role. He is playing the twin role. You won't be saying Varun Dhawan 2 times, yes or no. Similarly, here we have chlorine and chlorine, both are same. So I will be calling dichloro. Not only chlorine, chloro. I will calling it dichloro. If suppose there were 3 chlorines, so I will be calling it trichloro. 4 chlorines, tetrachloro. Bromo, ido, etc. etc. Are we good? Okay. So dichloro. Now, interesting point, you need to understand each and every point that 2 and 3, I use the comma. Maths, numerical value, friends. Comma, separated by comma. Maths, English, no brother, sister, only hyphen. 1 hand distance. Okay? So, you need to write it likewise. 2, 3, maths, comma, separated by comma. 3 and D are separated by 1 hand distance, hyphen. 2, 3, dichloro, done. Prefix is done. Word root, 1, 2, 3, 4, 5. 5, pent. Now, single bonded, double bonded or whatever. Single bonded in. Any functional group? Suffix? No. So that's your final name, 2,3-dichloropentane for this. Are we good? Are we enjoying this? Okay. Next we have this kind of structure, this kind of compounds. How are we going to name this? This is very clear. I have written this, Mr. Ramesh Singh. So this is your prefix. This is your word root. Don't forget that. This is your suffix. Done. Suffix is your surname. So, if I ask you whether you are going to, prioritize your surname or your Mr. Miss. So, you will be calling surname. Surname is very important because that's the legacy your parents or the grandparents have given to you. not Mr. and Miss. Okay, so you have to always understand this story when you are naming any functional group which is from the suffix side. You have to give it the lowest locant number, lowest possible number. Okay, let's check. I will be giving it 1, 2, 3, 4, 5, 6. And never 1, 2, 3, 4, 5, 6. Never. Why? Because suffix is always prioritized over prefix. Surname is always prioritized over Mr., Miss, Mrs., etc., etc. Done? Now, what can be the name? What can be the name? So I have the prefix, that is your 5-chloro. Done? Maths English hyphen 5-chloro. Then we have the word root hex, single bond ane. Then we have 3 all. English, maths, English, 3 all. Done. So basically we are going to have this. Now one more thing I would like to add here. Whenever you see 2 vowels all together, you cannot use that. That's not chemistry, that's your English. So you can ask this from your English teacher also. Why we are doing so? In the chemistry we have n number of rule, and then the English is also disturbing you. So the final name is going to be 5-chloro hexane 3-ol. This E is cancelled. Done? Okay. Now we have already I have discussed the lowest locant rule. Locant is nothing but your number. The number you are giving to your functional groups according to their preferences. Prefix is always having lesser preference as compared to suffix. Now, suffix has double bond, suffix has triple bond, suffix has OH, suffix has CHO, suffix has O, this one, and COH. Done? All these will be prioritized further more than prefixes, which are your fluoro, chloro, bromo and ido, and your CH3, C2H5, etc. Done? All right then. So we have, suppose we have some branch chain compounds. We have some branch chain compounds. So let's suppose we have this compound CH3, CH2, CH, CH3, CH2, CH3. So this is a very simple compound because the functional group I can say the prefix, primary prefix is situated in between 1, 2, 3, 1, 2, 3. So there is no confusion. Go either way. 1, 2, 3, 4, 5. Either ways. Okay, it is coming on the 3 only. So what can be the name for this compound? What can be the name? So name will be 3-methyl. As I told you, this is the branch alkyl group. I can call it carbon 1 methyl, carbon 2 ethyl. Done? Then we have word root pent, single bond ane, 3-methyl pentane. Are we good? Done. Now suppose we have this CH3, CH2, CH2, CH, C2H5, CH2, CH, CH3, CH3. Done? How can you name this? Now we have 2 branches. One is your methyl. You need to name it. That's important. It's your ethyl. How can we, how can we number it? So one is your 1, 2, 3, 4, 5, 6 and 7. Another, it can be 1, 2, 3, 4, 5, 6 or 7. How can we name it? How can we number it? What can be the idea behind it? So you need to understand, we will be using this side, not this. Why? You will be saying, ma'am, okay, we will be taking this only because we are having both here. Let's suppose I am not taking this CH3 here, but here. Suppose I am taking this, again it will be the same thing. It will be 1, 2, 3, 4, 5. So I can also take 1, 2, 3, 4. Okay. So I will be taking it here. Okay. Let's name it. Let's name it. Simply, we are going to name it. So 1, 2, 3, 4, 5, 6. So it's like this way. Now we are having this should be here C2H5. Okay, done. And we will be here. We will be having it here CH3. Okay, this is the question I wanted to discuss with you. So we are having a branch chain. Here we have the CH3 and we have this C2H5. Suppose 1, 2, 3. So the number 2 is given to this and number 6 is given to this. Suppose we are having 1, 2 and this is your 3, 4, 5, 6 and 7. So you will be very confused how to do this such kind of question. So my dear super champions, you need to understand that such kind of question, when we are having different kind of branches at different locations, go alphabetically. Alphabetically. So I know that alphabetically this is ethyl and this is your methyl. So I will be choosing this numbering. Why this confusion created? Because both the branches are on the same position. This is number 2. From this side, this is on number 2. I repeat, when this kind of confusion you can feel whenever the branch chain is on the same location on both the sides. So you have to use the alphabetic order. So ethyl is winning this match and the name will be 2. This is not going to work. Yes, I'm cancelling it so that there will be no confusion. 2 ethyl 7 2 ethyl comma 6 methyl heptane. Alphabetically, when two branches are located at same position. When two branches are located at the same number when counted from both the sides. So you have to check it by alphabetic order. Done. So this is how you are going to name such kind of compounds. Now we have, if we named a functional group to be given as suffix and the suffix, as I told you, two vowels cannot exist together. The former one has to be cancelled by the later one. Are we good? So this is your rule number 3 and this is your homework. Suppose you are having CH3, CH2, CH, CH3, CH, Cl, COOH. I'll hint you. Otherwise you will say, ma'am, you have done the easiest one and you are giving us a tough job. So basically this carbon you need to count. Yes, of course, this carbon you need to count, and this is coming from suffix side, so you have to prioritize this. That's okay. Now you can name it. So we have the chemical properties of carbon. So chemical properties we are going to discuss is combustion. Only 4 properties, which is combustion, oxidation, addition and substitution. One by one we are going to deal with them. So basically first is your combustion. So combustion is a chemical process. First of all, if you are burning a candle in presence of air, that is possible only then. So that is your combustion. So the requirement of combustion is your fuel, right? Your oxygen or the air having oxygen, and that's your fuel, heat and oxygen. Done. So basically a chemical process in which the fuel burns in presence of oxygen, that we call it combustion, and the result is heat and light. Result, let me write it for you. Result is going to be, we are going to get energy in the form of heat and light. Right? Now hydrocarbons are generally named as CXHY. So it can be anything. Suppose you are having CH4. If you are going to burn it in the presence of oxygen, it will always give you CO2 and H2O. Now the amount of CO2 and H2O is produced is depending on the size of hydrocarbon you are going to burn. Are we good? So this is what we have in the combustion. Next is, we have 2 types of combustion. We are going to deal with them one by one. So basically complete combustion, as the name suggests, there will be complete supply of oxygen, because combustion depends on the fuel, oxygen, supply of oxygen and the heat, amount of heat. So basically a combustion, a chemical process in which fuel burns in excess or more than enough oxygen, so that is known as complete combustion. For example, we can see that complete combustion is characterized by a blue flame. Have you ever seen in your kitchen, sometime your mama can say that there is the flame is in the orange color, and sometime you see it is in the blue color. What that indicates? Complete combustion means the flame color will be blue. That means it is getting the sufficient oxygen. There is no blockage. In your kitchen, the stove has something like this, and there are holes, tiny holes, from where the gas particles are moving and they are catching fire. And this is in the blue color if there is no blockage. But with respect to time, when there is lack of hygiene, your stove holes can get blocked, right, due to which there will be incomplete combustion, and there will be what? There will be orange dirty flame. Orange dirty flame. Okay. So it is always advised to clean the stove after each use, after every usage. Flame is dash, then the flame of incomplete, that is your hotter. Blue flame results due to complete combustion, so it will be hotter as compared to the incomplete. Incomplete combustion, the hydrocarbon burns to produce water vapor along with carbon monoxide. See, if your carbon forms 2 kinds of oxide, CO2 and carbon monoxide. CO2, when we exhale, that is your carbon dioxide, because we are inhaling sufficient amount of oxygen. So carbon is combining with excess of oxygen, making carbon dioxide. But in incomplete, we are not having sufficient amount of oxygen, and that's why carbon monoxide is formed, the little one. So carbon monoxide is poisonous. It's not good for environment. Yes, I agree. Larger production of CO2 is also not good, because that is responsible for global warming. But again, CO, carbon monoxide, is actually poisonous. Now, produce black color soot, that black ash, the carbon particles, burnt carbon particles that will stuck to your utensil and will make it look blackened, right? In your NCERT, you might have the question why the utensils, when we are, cooking something and they get blackened, because of there is blockage in your stove, and that is raising the issue of incomplete combustion, and due to which the unburnt carbon particles are getting stuck to your utensil and making it blacken, right? So carbon monoxide is poisonous. We have done this, of course. So basically now we have to understand that complete combustion and incomplete combustion have different clear differences. One is it occurs in the sufficient amount of oxygen, while insufficient amount of oxygen is available. Hydrocarbon. So basically the hydrocarbon on combustion gives you the carbon dioxide, and here carbon monoxide and water vapors are present. As I told you, less oxygen, carbon monoxide. Excess of oxygen, carbon dioxide. Simple. Flame. Blue color flame, yellow, orange, dirty flame. Here we have smoke. No production of smoke, because everything is utilized in making the blue flame, bright blue flame. Now it is produced, smoke is produced because the whole efficiency of fuel is not used. So it will produce smoke or the soot. Energy production is high, of course, more efficiency. Energy production is low because there is more wastage of a fuel. Next we have environmental issue. Of course, both are not good for environment. But yes, CO2 is only responsible for the global warming and is not poisonous. If we are using it in the limited amount, it's not bad. But we know that carbon monoxide is a major component of air pollution, and also it is poisonous, so it can cause death even. Now we have oxidation. Oxidation, as the name suggests, in the chapter 1 chemical reaction and equation, we have discussed the redox part, reduction and oxidation. So oxidation is something, oxidation stands for addition of oxygen, removal of hydrogen and removal of electrons. This is the shortest definition I can write for you. Plus means addition, minus means elimination or removal. Done. So basically oxidation is the reaction that occurs in the presence of oxygen, is known as oxidation process. Requirement is your catalyst and oxidizing agent. I hope you understand what is your oxidizing agent. Oxidizing agent is responsible for oxidation. So basically catalysts are the chemical species, substances which generally increases the speed of reaction, right? And they do not consumed during the reaction. Suppose you and your friend are having some kind of conflicts, having some kind of misunderstanding. So one of your mutual friend will, will make a meeting for you, kind of, to make everything settle between both of you. So now this M is nothing but the catalyst. He has nothing to do with the stuff you both are having, A and B, but yes, he is going to settle them up. So M is something catalyst, increasing the rate of reaction, friendship zone, and also not consumed during the reaction because it has no problem with A and B both. Are we good? So that's your catalyst. Now, oxidizing agent is something like that is going to oxidize your hydrocarbon. That is going to oxidize your hydrocarbon. That's okay. So that's your oxidation. Now, what we have in the example? Okay, example. My goodness. Okay. Here, it's okay. We have the oxidation reaction. Most of the important, you can say, the reaction. The oxidation of alcohol, CH3, CH2, OH. In the presence of oxidizing agents such as acidifying, that means in the acidic medium we have acidified KMNO4. You can check how many oxygen it can carry, lots of. So it can add oxygen. That's why it is working as oxidizing agent. Another one can be the alkaline KMNO4, potassium permanganate. Check the number of, okay, KMNO4 and K2 Cr2O7. Potassium dichromate, potassium permanganate and potassium dichromate have a lot of amount of oxygen they can add. Okay, now as we know that oxidation is a process of addition of oxygen and removal of hydrogen. So here I can see removal of hydrogen. I will remove this and will be adding one oxygen here and it will be CH3CO. Everything is same. Everything is same. You can check. Only this oxygen is replaced. Only this oxygen is replaced by this H2 removal. And this is your addition of oxygen. Now you will be asking, ma'am, we have removed 2 hydrogen and added only 1 oxygen. So you need to understand 1 hydrogen carrying 1 positive charge, 2 hydrogen carrying 2 positive charge. Yes or no? In order to maintain the neutrality, 1 oxygen carrying 2 negative charge. So 2 negative charge means 2 valency. Yes or no? So that's why in order to balance it, 1 oxygen is going to be replaced by 2 hydrogens. Are we done? Good. Important reaction. Important reaction. You can, replace it likewise. So there will be no confusion. Now we have the difference between oxidation and combustion. Many times in class 8 and 9, we have understood these terms n number of times. So there is a very fine difference between these two. So basically oxidation is a substance when react with oxygen in presence of air or water. If you see the rusting of iron, that is also a kind of oxidation reaction that happens in the presence of oxygen, right? Moisture. So that's also an oxidation. Combustion. Combustion involves burning. Oxidation reacts with oxygen. Combustion involves burning. A big difference. So you can clearly say in combustion you can get products as fire and light. Heat, fire, light. Here it may or may not produce fire or light as a result. Done. Combustion do not require any oxidizing agent or catalyst. You just require flame, heat and your fuel, heat and your oxygen. In this case, you required some kind of catalyst. Now you have all combustion reactions are a type of oxidation reaction. So oxidation is the father, big feature, big movie, big picture. So combustions are kind of oxidation process, but oxidations are not the combustion process. Are we good with this? Are we getting this? Okay. Now we have the addition reaction. As the name suggests, we are going to add something. What something? Only hydrogen. We can add only hydrogen because carbon has greater affinity for hydrogen. Carbon has a best friend relationship with hydrogen. Okay, so unsaturated hydrocarbons, unsaturated means doubly or triple bonded compounds, alkene and alkynes, add hydrogen in presence of the catalyst such as palladium, any metal like palladium, nickel, platinum, to give saturated hydrocarbon, unsaturated to saturated. Conversion is possible. Catalyst, what are catalysts? Again, we are going to define it. Catalysts are the substances that cause a reaction to occur, proceed at a different rate, generally increased, without the reaction itself being affected. Self are not going to get consumed. Now, my dear students, this reaction is commonly used in hydrogenation of vegetable oil. Now, reaction is always important because these are the chemical reaction of carbon. So, reaction is, suppose you have CH2. In presence of, you have to write it, nickel or palladium. What will happen? What will happen? You are going to add what? Hydrogen. You are going to add hydrogen. So, just be patient and check the reaction yourself. What will happen? Carbon can only form 4 bonds. In order to add these hydrogens, carbon has to break the former bond between carbon and carbon. So, suppose this bond is broken. 1 electron here, 1 electron here. Check the electrons only. Now, this hydrogen is also placed like this. 1 hydrogen, 1 hydrogen. They were having bond, but when we see they are going to join with carbon, they have to bribe carbon with the shared electrons. So, carbon also break bond with the another carbon and joining with this. So, what has happened here? I will show you what has happened here. This bond is broken, new bond is formed. Breaking and making of bond happened. So, basically now we have CH3, single bond, CH3. Can you see this? Can you see this? What happened here? So, this is happening. What is happening? Addition of hydrogen in the unsaturated hydrocarbons and making the saturated one, single bonded hydrocarbons. Name ethene. Now, ethane. Big difference. Can you check it? Addition reaction, you are adding something. So, if you want to add something, you have to make the place. So, carbon along with carbon will be breaking the bond and will bribe these share electron to the upcoming hydrogen and will be forming a bond. So, unsaturation to saturation. Are we good? So, this is your addition reaction. What about the substitution reaction? Suppose you have your English subject. You have your English period and suppose your English teacher is absent today. So, what will happen? Maths teacher will come. Science teacher will come to substitute the period, to arrange this period. So, what happened here? They have exchanged their seat for some time. Substituted. So basically what is happening, English teacher is not here, so science teacher will be taking place of it. That's your substitution rearrangement period. So here's unsaturated. We have already discussed that the unsaturated have the capability to break the bond and they are reactive enough. What about the saturated? What about CH3 double bond CH3? If I want to add something here, if I want to add here hydrogen, so can I do that? No, because carbon-carbon bond will break. If carbon-carbon bond will break, so this CH3 and CH3, they are not stable. Nothing happened, only destruction. This will not happen. So, what if your single carbon compound, they are tends to be less reactive because they have single bond with the another carbon. They cannot break it, they can give you n number of compounds. So, they are supposed to be less reactive. Okay. So, what kind of reaction they can do? They can do the substitution. Let me show you how this happens. So, let's make it beautiful. Don't sleep, just check it out. So, we have, suppose we have Cl2. In the presence of sunlight, this kind of reaction can occur in the presence of sunlight, because in order to break the old bond and in order to make new bond, we require energy. So, sunlight will work here. So, this sunlight, in presence of the sunlight, this Cl-Cl bond will break. Done. Also, this CH bond will also break because the carbon is liking this Cl. Carbon is liking the Cl and asking, come here. Why don't you substitute this hydrogen? I already have 3 hydrogens. So, this Cl come, substituting it, and the hydrogen is substituting Cl. They are exchanging the partners. Are you getting my point? Just like in the double displacement kind of reaction, the Cl is coming here and the hydrogen is going there. So basically by product will be H, C, H, H, all similar, now Cl, and it will be HCl. Can you name it? Can you name it? So this is your methane. After substituting this chlorine, it has become the chloromethane. Are we good? So this is what we call the substitution reaction. One interesting point I would like you to do it in your notebook, that all these 3 hydrogens can be substituted by other chlorines. So every time chlorine will not come singly, it will come in the form of Cl2. Every time this hydrogen, next hydrogen will go, Cl will come and forming Cl, Cl, H and H, and again HCl. Reaction will occur in the presence of sunlight only. Are we good? So you can replace all these hydrogens. Done? Okay. So displacing, substituting, rearranging, that's called the substitution reaction, and that is done by the saturated compounds, or you can say the alkanes. Now we have ethanol, some important compounds of carbon. One is the ethanol and the other is your ethanoic acid. So basically the formula for ethanol is C2H5OH. What is it? We are writing it like CH3, CH2OH. In the compact form, I can write it C2H5OH. OH will be separated because it's showing the functional group. Done. Now the common name for ethanol is actually ethyl alcohol. The most commonly alcohol we are using for the beverages. Now, what can be the other kind of uses? When containing 5% water, that means 95% alcohol and 5% water. What is it making? It is making rectified spirit, right? And we are using it for the commercial alcohol. Next we have the 100% pure alcohol, which is known as absolute alcohol, and it is undoubtedly poisonous, or you can say lethal, can cause death. We have the power alcohol in many countries. See, petrol has some additives. Yes, in every country we have petrol up to 95-96%, and then we add some additives so that it works efficiently. It does not stick to your engine because petrol has, or the diesel has, a sticking property. So that's in order to prevent that, eradicate that, we use some additives. So in some countries we use alcohol as the additive. So what is the composition? 20% absolute alcohol, that means 100% alcohol, and 80% petrol is used as additive in the fuels, right, in some countries. Are we good? Done. So next we have the properties of ethanol. Ethanol, you can see it is colorless. Volatile means can be converted into vapors. It's flammable, colorless liquid with light odor. Now it is produced by the fermentation of sugar. We are not asked how we are preparing it, but yes, you can prepare it by the fermentation. Ethanol is commercially known as alcohol and is the active ingredient of all alcoholic drink like wine, beer, etc., etc., having different composition or the percentage of alcohol. Now, ethanol is also soluble in water in all proportion. We have heard about the PAGs, right? So that is a very fine example of how water and ethanol are soluble to each other. Then next we have the uses. It is largely used as a solvent in paints, liquors, beverages, dyes, cosmetic, perfumes. You have used the sanitizer? Yes, in that also. Tincture and cough syrups always. Yes. Next we have the important starting material, manufacture of ether, chloroform, iodoform, etc., and anti-freezing in the automobile radiators. In the winters, the countries which are having icy weather, radiators get frozen. That's why we are using there also anti-freeze. Next we have the reactions, the most important part. Reaction with sodium. So we have CH3, CH2, OH. You always have to write it like this. Yes, I'm showing how this reaction is working. No need to cram, just need to understand. So we have sodium. Sodium, it is reacting. So basically what happens? This oxygen is bored of this hydrogen. Everywhere in the alcohol, oxygen is standing by the hydrogen. Now, hydrogen is a poor guy. Nobody likes him. Nobody means nobody. So this oxygen says, I just want to get rid of you. Just go. Just go. So this sodium will be taking place of it. Yes, of course, in order to, see, life is all about give and take. Yes. So if this hydrogen is going, so sodium is coming. So it is CH3, CH2, ONA, which is sodium ethoxide. Sodium ethoxide. How will you name this? Ethoxide. Simple, simple. You check it. Sodium, sodium. Eth, 2 carbons. Oxide, oxygen is present. Sodium ethoxide. And what about hydrogen? Hydrogen cannot live alone. Poor guy wants another poor guy to cry on the shoulder. So it will be existing as H2. Yes, of course. So this is your reaction, important. Again, I'm telling you carbon. The whole chapter is itself important because you can also see the PYQs. You can also see the pattern of the CBSE every time. We are having the great questions, the repeated question like why carbon is versatile nature, oxidation property of ethanol. We are making what? We are oxidizing it into ethanoic acid. Yes, So now we have the reaction to give unsaturated hydrocarbon, of course. Unsaturated. Keep this in mind. So this is your CH, H, H and H. What we are having? Reaction to give unsaturated. So we have CH2H, CH2, and we have, of course, we will be writing it like this, CH2H, CH2OH. I am rearranging ethanol. Ethanol is this. I have written CH3 as CH2H. Any problem? I have written CH2OH as CH2OH. Now, what will happen? We are going to use concentrated H2SO4, sulfuric acid, H2SO4, king of chemicals, which is your dehydrating agent. Dehydration means when you are not consuming enough amount of water, your body will be dehydrating. Yes, lack of water. So, H2SO4 has a property of dehydration. Wherever you are using H2SO4, it will absorb water. It will escape water in fraction of seconds. So, here, why I have written this? I hope you are going to get it. H2SO4, this H2O. Disappeared. If this is disappeared, what about the shared electrons? 1, 2, 3 and 4. So, these electrons are taken by HNOH and will be forming H2O. Then, what about these? They will be making bond and it will turn into CH2 double bond CH2, which is unsaturated compound. And this reaction occurs at 443 Kelvin temperature. In the higher classes, you will get the dehydration of water at different temperature. Here we have only one, which is at 443 Kelvin. So basically, we are dehydrating this ethanol, removing the water and making it unsaturated compound, which is your ethene from ethanol. Are we good? Are we good? You just have to do one thing. You just have to check these reactions. You have to write it likewise, and I guarantee you, you are going to rock in the examination. Now, ethanoic acid. So, basically, we are going to deal with ethanoic acid. What is it? When we are oxidizing the ethanol, it will form ethanoic acid. What is that? So, ethanoic acid, as the name suggests, it is one kind of acid, organic acid, organic weak acid. So, and it is deriving from the Latin word acetum, that means sour. Sour means acid. Sour or the sharp wine. We call it vinegar also. Vinegar. Vinegar is only 5 to 8% of acetic acid. That means if you are taking 5% of acetic acid, 95% will be water. And that dilute solution, you call it vinegar. And you consume it in the preservation of alcohol. You consume it in the fast food, right? Your noodles, etc. So, ethanoic acid is commercially called as acetic acid, and it belongs to a group of acid called carboxylic acid. What is the chemical formula? That's your CH3COOH. Are we good? So this is your, or you can also write it like this, CH3COOH, or you can also write it RCOOH. This is your carboxylic group, the family of acetic acid. Then R group can be anything. Now we have the properties of ethanoic acid. It is again colorless liquid with sour taste, smell of vinegar, 5 to 8% of solution of acetic acid in water is known as vinegar, and we use it in the preservative of pickles. Melting point is so and so, not that important, and it get freeze during the winter in the cold times, right? And it forms some ice flakes and we call it glacial acetic acid. Glacial because it freezes. Yes. Now next we have the reaction of ethanoic acid. Again, esterification, formation of esters. Now what are these? These are kind of a functional group that we are not including in the class 10, but of course in the higher classes. And esters are the sweet smelling substances which we use in the formation of perfumes. You have the flavoring agent, etc. and etc. What can be the reaction? So we have esterification. This is your ethanoic acid come along with your ethanol. Oh my god, we have two important compounds of carbon in this chapter. Bring them together, ethanoic acid and ethanol. So I am placing them likewise. CH3COH, done. CH2CH3OH. Any problem in that? Because I want to show the proximity. This reaction is going to happen in the presence of concentrated H2SO4. Can you tell me what is going to happen? Yes, removal of water. So from where? OH and H disappear. You can also do one thing. You can take OH from here and H from here in order to make the water, right? That's why I have placed them likewise so that you can get the idea of reaction. How is it happening? Now whatever is behind, just place them all together. CH3, COO, we have CH2, CH3. What is it? It's your ester, ethyl ethanoate, ethyl ethanoate. Are we done? So that's your ester, COO group. COO group. COOH group is the carboxylic, right? CO is the ketone. And what about COO? Ester group. Ester are the sweet smelling compounds. So that's your esterification, formation of ester. When it is coming? When ethanol is added to ethanoic acid. They will form ester. Are we good? This can be important as well. Now we have the another, which is reaction with the base. Alright, no problem. Suppose we have CH3, COOH and NaOH, alkali, base. So I would like to know from you, when acid reacts with base, what happens? Yes. So this is your acid, of course, and this is your base. Just have to write what is gonna happen. Salt plus water. So how is this reaction gonna happen? Again, oxygen wants to get rid of this hydrogen, asking it to leave, and this Na will take the place. So this H and OH will be making H2O. Done. And this salt will be what? CH3 COO Na. Sodium salt of acetic acid. That's your reaction. That's your reaction with the base. So basically, what is the mechanism? You just need to understand what are we reacting with. Acid, base, salt and water. That's all. Reaction with carbonate and hydrogen carbonate. Alright, we have CH3, COOH. Suppose we have NaHCO3 or Na2CO3, no matter what. Both are going to react in the same way. So we have this. Again, this hydrogen is the problem for this oxygen. Wants to get rid of this. What will happen? Sodium will come out. Sodium ready to replace this hydrogen. Okay, so it will be CH3, COONA. Done. First, I would like to give you one hint also. This is your acid. In acid, base and salt, we got to know that sodium bicarbonate is a kind of base because it is derived from the combination of strong base and weak acid. Are you getting my point? Now, so this is your base. Again, you are going to get a salt plus water. But if you are talking about carbonates, it will also give you CO2. Done? That's your reaction frame. Water. How? This HCO3 is not stable. Na is gone. So this will give you CO3 will be stable in CO2 only. Carbon dioxide, have you heard it? Yes. CO3 is not stable. It will give you CO2. And this hydrogen will get combined with this hydrogen along with extra oxygen. It will also give you OH. So, you can see water and formation of CO2. Now, the CO2, you can detect the presence of CO2 by lime water test. Lime water test. Now, this is your homework. Do let me know in the comments what is that lime water test. Yes? Okay. Now we have another part which is your soap and detergent. Oh my God, there is a war between soap and detergent. So we are going to understand this difference between soap and detergent. So basically soap is the sodium salt or potassium salt. Sodium salt and potassium salt of long chain of fatty acids. Fatty acid means group of carboxylic acid. Now potassium salts give rise to formation of soft soaps like your Dove, Pears, etc. Girls are using these days, and the sodium salts are giving rise to result to what? Your hard soaps. Like, can you name it? Lifebuoy, etc. Okay, I will not name much of them. But yes, you can understand it. So, these are the long chain of sodium salt or potassium salt of fatty acids. Are we good? Now, my dear students, they are having the cleansing action in water. Now, I would like to add something. Before 17th century, there was no name of hygiene. Yes, you heard it right. So, very first, the Greek people used to, bath with the soap and etc. and they love to have different fragrances. So they did many experiments and come up with the soap, the cleansing action. So basically we before us or any other mankind on this planet, they started the ritual of bathing. So did you like this fact or not? Do you like bathing or not? Do let me know in the comment, because it's the time of winters. No one wanted to, go to the washroom and take the shower or etc. But you need to take it. Sodium stearate or sodium palmitate. Long chain of fatty acid. If you're not able to recall that, so you can simply write it like long chain of fatty acid. Sodium stearate having the formula C17H35COONA. Salt of sodium. You can also write it here potassium. Again, we have the palmitate C15H31COONA. Are we good? Now, sponification, as the name indicates, sponification. Okay, one O is extra. Formation of soap. Formation of soap. So I would like to know, are you recalling the esterification, the formation of ester? Yes or no? So we are taking that product here. What was that product? It was CH3, CH2, sorry, CH3, COO, C2H5. Yes? Or you can also write it like CH2, CH3. Done? Otherwise, you will get confused. You have to react it in presence of base or alkali like NaOH. How do you react it? How do you react it? Simple, simple. You have to do one thing. This oxygen is not liking this carbon. Have breakup. Now, Na positive, OH negative also have breakup. Whenever you see this sodium now, something gonna happen. Making and breaking gonna happen. So, this oxygen and carbon bonds break up. So, this sodium, because we know that oxygen is negative, non-metal. Now, you will say, ma'am, also the carbon is non-metal. But oxygen has, see, carbon always share electron, not gain nor lose. But oxygen gains electron, carry 2 negative charge. So it is negative. So most probably it will be positive. That's why they are connected together. Positive, negative attracts like anything. So this Na positive will attack here, and this OH negative will attack here, and will be forming corresponding CH3 COONA plus CH3 CH2OH. Done? Can you name this? Can you name this? Is it a salt of acetic acid, sodium salt of acetic acid, or you can also say sodium salt of fatty acid? If you are increasing the number of carbon and hydrogen like C17H35, COONA, so what is it? It is the soap. Oh my God. Yes or no? And that's your ethanol. That's your alcohol, simple alcohol. So, here one thing I would like to let you know that sponification and esterification are reversed to each other. My dear students, I would highlight one point here. When ester is turning into the soap and alcohol, we are using the base. And when these both are going to combine, they are going to happen in the presence of acid. You just need to recall this point. You just need to understand this point. Are we good? Now, let's move to the next. That's your micelles. So, micelles are nothing but your cluster. When you are adding the soap into the soft water, it will form the leather. Yes. So, that is having a cluster. That we call it micelles. So, the cluster of molecules in which hydrophobic tails are interior of the cluster and ionic ends at the surface of the cluster, this formation is known as what? Micelle. Now, what is this? Hydrophilic. What is this? Hydrophobic. So, I would like to explain you the action, cleansing action. So, you are adding the soap into water, right? So, it will be having micelles. It will be having two ends. One will be hydrophilic. One will be hydrophobic. One will be hydrophilic. One will be hydrophobic. Philic means loving. Hydro means water. Done. Hydro means water. Phobic means afraid of, frightened of, right? Phobic means frightened. As you are afraid of your exams, similarly, these are afraid of water. So they are not going to deal with water. They are not talking to water. They will be away from it. So if they are going to be away from water, what is going to be near to water? We are adding soap water into the dirt that is on your cloth, right? Dirt are generally hydrocarbon, or you can say oily in nature. Why oily? Suppose if the dirt is in the form of dust, you can just clean it likewise. But these stains are very rigid. They are not, we are not doing this. We have to wash it with using the soap or the water. So this is your action. So now I would like to let you know this structure C17, H35, COONA. You can see this will be positive, this will be negative. So this is your ionic part. You can clearly see the ions. This is your ionic part. We call it polar. Having charges, we call it polar. And this part is carbon and hydrogen. No charges. That means non-ionic. Non-ionic, we call it non-polar. Non-polar. And we can also write it like this way. Because every time we cannot, recall this C17, H35, CONA. We are, representing it a structure, that is your tail, and this is your head, like a tadpole. So this is your head. Everything is written here about head, and this is your tail. Everything written here is about tail. Non-polar. Are we done with this? Are we done this? Are we done with this? Now you need to understand this polar part, this ionic part is hydrophilic. That means it's going to love water. Now you will be saying, ma'am, how we need to recall these number of terms? So you can clearly see this is an empty ball. You can fill water into it. So it is your hydrophilic part, right? So of course it will be your hydrophobic part. Hydrophobic. Are we done? So this is how you are going to understand. This is only one part of your cluster. Now all of these are going to join together. How? Suppose this is your cloth and we are having dirt on it. Have you seen the advertisement like Surf Excel, etc., etc.? They show you the cleansing action, how this happens. So basically, similarly, we are having to see that only. So what will happen? This is your dirt, oil. So hydrophobic, oil, hydrocarbon. So in this cluster, in this structure, this is your hydrophilic and this is your hydrophobic. So in the case of, we get the majority, brotherhood. So this will attract the person like it only. So what will happen? This part. I can show it like this. So they are forming a cluster and we call this cluster as a meshal. Then this is your meshal. So what is happening here? This hydrophilic part is towards water. Hydrophilic. The ionic part. Be very ready because these terms are very important. Examiner can ask you either ways. Right? What is hydrophilic? What is hydrophobic? You should know it. So what is happening? It is making a meshal. In between, we are having what? The dirt. Slowly and steadily, this dirt will be removed and will be rinsed by water, and that's how we clean our clothes. Are we good? Done? So now we are going to discuss it with the help of these fancy lines, line by line. Soap in the formation of meshel is able to clean since oily dirt will be collected in the center of the meshel. Here you can see these are the particles that are coming, and these are your dirt. So they are going to stuck on these and will be forming this kind of structure. So dirt is in between and the meshel is forming the cluster. The meshel stays in the solution as a colloid and will not come together to precipitate because of ion-ion repulsion. Now you will say why these are always making such structure? Because these ionic parts are all together. They will be repelling each other, you know, attraction and repulsion. So this is Na positive, Na positive, Na positive, Na positive, Na positive. All are repelling each other and maintaining the structure. Done. If they were attracting, everything would have been vanished. So due to ion-ion repulsion, the dirt suspended in the meshel is also easily rinsed away. This will be rinsed away. The soap meshels are larger enough to scatter light, and that's why they look cloudy. Have you seen the meshels? Yes, they look cloudy because they comes in the category of colloids and they can scatter the light. Now there is one more point, which is scum. So we have two types of water. One is your hard water and two is your soft water. In the hard water, we have the impurity or the salt mixed of calcium or magnesium sulfate, chlorides, etc. What happens? Soft water. Just cleansing action of soap is shown in the soft water only, and it do not produce leather in the hard water. You can clearly see here in the soft water, is it making leather? The cloudiness is here. But in the hard water, you can see the precipitation. We call it scum. Done? Not making the leather. But hard water and soft water, we can see the cleansing action of detergent. So detergents are the very powerful person. That's why we are using, that's why soaps are way concentrated on bathing etc. only, but the detergents are using in the cleansing of your cars, washing your clothes, washing the laundries, the dry cleaning etc. etc. So soap differs from detergent in the action of hard water. Soap cannot be used effectively in the hard water as they produce scum, not the lather. Due to presence of these ions, while detergent do not produce insoluble precipitate in the hard water, and they are effective in the hard water as well. So we have CH, suppose we have C70, H35, COONA. This is your fatty acid, sodium salt of fatty acid, your soap, which is reacting with calcium chloride, the salt that is present in the hard water. From hard water, you can also write here magnesium chloride, magnesium sulfate, calcium sulfate, any of the salt. Now what will happen? Again, what will happen? This sodium and calcium will be displaced and it will be forming CH, C17, H35, COO, calcium, C17, H35, COO plus NaCl. So this can be soluble, but this is your scum, which is insoluble. Why I have taken 2 units of C17H35 COO? Because you can see 1 negative satisfied by 1 positive. So calcium is 2 positive. So we require 2 negative units to satisfy this chemical compound. Done. So we are making the scum here. But detergents are very powerful. They do not react, they do not entertain the sulfate salt or the chloride salt of calcium or magnesium or any other metal. Done. So detergents, what are detergents? So as I like 17H35CONA. What is it? The general formula for soap. If I want to write it, the general formula, it will be RCOONA. Done. What if I want to write it for the detergent? It will be RSO3Na. RSO3Na. That's the only difference. R unit can be the same, but the after unit, the ionic part is changed. So detergents are generally sodium salts of sulfonic acid or the ammonium salt with chloride, bromide ions. Both have the hydrocarbon chain. In the higher classes, we will deal with the detergents pronouncedly. The charge and of these compounds do not form insoluble precipitate. That means they do not entertain the salt of the hard water and will not form the precipitate. In fact, they will form the leather. So they remain effective in the hard water. Detergents are usually used to make shampoos and products for cleaning clothes. Are we done with this? So this was your detergent. Now soap and detergents have differences, very clear differences. You can check in one space only. They contain sodium carboxylate group. They contain sodium sulfonate group. The ionic part is changed. Now, they are not suitable for washing with the hard water. They are suitable for both hard and soft. They have relatively weak cleansing action, because you can say that, my dear students, they are depending on the nature of water. Action is weak, action is strong. Now they are biodegradable. Whenever you see many good parts, so coin has always two faces. So the bad part about detergents is they are non-biodegradable. If the clothes are to be washed in the open rivers or the any river bank, etc., so the leather formed will be for a longer period of time and it will affect the aquatic life. So these are non-biodegradable while soaps are biodegradable. So this was about today's session. We have mastered carbon and its compound in one shot. I hope you have enjoyed the session, because I have maintained the energy throughout and I believe the same from your side. So thank you so much. I hope you are preparing well for your exam. Don't get afraid. Go for your strategies, go for more practice, and do not forget to do your PYQs. As I told you in the very first, get ready with your pens. P, the PYQ, E is your exemplar, N NCERT, and H your sample paper. Thank you so much. We'll be seeing you very soon. God bless you all.